All right, here we go. So just because I started recording, here's the formula that I'm going to give instead of that for the total resistance in parallel. The battery symbol looks like that. Make sure you know that this is the longer line is the positive terminal, the shorter is the negative one. And the current always flow from the positive to the negative, right? So if you were to draw the current in a circuit, it would flow away from the positive and towards the negative in a loop. A resistor. A resistor, somebody else. A resistor has this. This is how what a resistor looks like in a circuit, okay? A switch, an open switch looks like this. That's open. But if you were to, so that's an open switch. But if it was closed, you know, those dots, you simply have it like this. All right. The bulb looks like this. Sometimes the bulb is drawn like that. And other times you'll see like this is the filament of the, you know, the LED bulbs are a little different. But in the older bulbs, you have this element which had tungsten is the metal in it, but like a little squiggly wire in it. It's called the bulb filament. So that's how we draw it. So those symbols you should know. Now you should also know the units. So when you're doing all the problems, make sure you give me the units. I'll always put an extra blank for the units. The resistance has units ohms. Like that chant ohm, like, right? That's literally how one physicist, the physicist was named after that chant by their dad. And the symbol is like this. So just remember the chant. All right, current is the amps. That's the ampere, another physicist. The short for that is amps or simply A. So if it's 1 amp current, just 1A. Volts is the voltage. That's what you see on your battery. V is used as a shorthand. The power is watts, but we didn't do that, so get rid of that. This year we didn't get into power. We did the power for other things, but not for electrical. All right, so the formula you need to know, okay, is Ohm's law. You need to understand what each symbol represents. So let's write it down first. V equals IR. That's the formula that relates voltage, that's your voltage in volts, to the current. I is used for current instead of C, because C is used for something else. And R is for the resistance. So that is Ohm's law. Now we're going to do calculations. So basically on your test, I'm pretty much going to give you more like calculations, and you may have to draw a circuit somewhere too. And the calculations will either involve just a single resistor, and I may give you 2 out of 3 variables on that formula, or it'll be a series. There will definitely be a series. There will definitely be a series circuit and one parallel circuit. Okay, and some problems like this one. If a resistance of a device is 50 ohms, what's the current through it if it is connected to 120 volt power supply? Can't stress enough, when I say show the work, this is what you need to show me on the test. It helps me give you as many points as possible if in case you make a mistake. If you just scribble 2 numbers divided and you get a wrong answer, I really can't give you much on that. So if you show me that, look, you understand that resistance in this circuit, the resistance is 50 ohms, and that you understand that you're looking for current because it says, what is the current? So I equals question mark, and then that there's 120 volt power supply. So the voltage in the circuit is 120. Then write down the formula you're going to use. Again, don't just scribble a bunch of numbers because I won't know how much you know. So then plug in. So under V, plug in 120. Don't put your units in. Unknown I, just keep it as that. Don't put a question mark for it. Times 50. So all you got to do is now divide both sides by 50 because you're trying to calculate the current. You divide by 50 on both sides. So you have I on one side. Flip the equation so that I is 12 divided by 5. What is 12 divided by 5? 2.4 or right? 2.4, that's good. Amps. All right, amps. So something like this. By the way, when I give you a problem of this sort, I may give you, I may ask you to calculate V and give you I and R, or I may give you, so I'll give you just 2 out of those 3 variables, okay? It could be any of those. So you're gonna have some problem or problems like that. Now here are some general things about series and parallel circuits. Let's review those. So if the statement about a circuit is true for a series circuit, place S. And if the statement is true for parallel, then put P. All right, let's first review what series and parallel are like on the side. Remember, if you have, let's say there are 2 resistors in series. Series means they're all in a single loop, right? Like so. That's series. And the current, again, always goes from the positive to the negative. So current only has one path. It's the same everywhere. The current does not split. If the current does not split, then the battery voltage splits. So if this is your 12-volt battery, that 12 volt is going to split between these 2 resistors, and the larger resistance will get the larger voltage. If both are equal resistors, then the split is half, 6 volt, 6 volt. That's your basic on series. Parallel circuit, on the other hand, if you have 2 resistors in parallel, let's just review that as well. That's how you draw them. Here, clearly, if you follow the current, it splits at this junction, right? Think of the wires as roads. So if on a road the traffic is going and it comes to this junction, part of the traffic goes there, part there. And the split is such that the larger resistance will have a smaller current. Resistance means how much it resists current. A larger resistance gets a smaller current. But the split is such that if you have this R1 is being this resistor R2, the current through 1 and the current through 2 add up to this main current that goes through the battery, the I total, okay? And then this current recombines here and goes back and through the battery. And another thing, remember, battery does not supply current or charge. It supplies energy. So we don't charge a battery, we energize, in a way, a battery, okay? All right, now let's look at these statements and we should be able to answer them. Out of these 2 circuits, let me again write down, this is the parallel. Out of these 2 circuits, in which one there are multiple paths to current? Parallel, obviously. So P. In which one there's only one path for current? Obviously, it's series. Current is the same at every point in this circuit. Which one? Series. Series, there's a single path, single loop. In series, it's the same everywhere. The total battery voltage is equal to the sum of the voltage drop at each resistor. In which case? In which case does the voltage split between the 2 resistors? Remember, if the current does not split, the voltage splits. It's always the other way around. In series, the current is the same, so voltage splits. So, yes. By the way, in parallel, I forgot to remind you that because the current splits, remember we discussed that the voltage is the same. The voltage across both of these resistors will be the same as the battery. So if it's a 12-volt battery, you'll find 12 volts here, 12 volts, but the current is going to be different. Remember, it's always the other way around. If the current is the same, the voltage splits. If the current splits, the voltage is the same. The voltage across each bulb is the same and is equal to the battery voltage. As I just mentioned, it's the parallel. Any questions so far? All right, let's do the next one. So what happens to the total circuit resistance? We did a bunch of labs in which we explored this too. So what happens to the total circuit resistance when more bulbs are added to a series circuit? So if you have two series circuit and I add a third one in series, what's going to happen? What's going to happen to the resistance? Does it go up or down? Resistance is kind of like an obstacle. It's not really an obstacle, but it slows down current, right? So if you add another one in the line, imagine if current was like traffic and resistance was some sort of a thing that is slowing it down. You add a third thing that slows it down, it's going to overall reduce the traffic flow. So adding extra resistors in series actually increases the current, increases the resistance. The circuit resistance increases. And if the resistance goes up, the current goes down. Let's also add that. So here they're talking about adding more bulbs, right? Bulb also has resistance, so the same applies to adding, if you have two bulbs and now you add a third one in series, the resistance increases, the current decreases, and they will become less bright. And it results in the dimming, all right? They become dimmer than they were. So if you have a series circuit and suddenly there was a break in the circuit at any point, if the wire snaps or maybe there was a switch that's open, can the current flow? Will the circuit work? No. There's only one path. It's almost like saying if you have traffic and there's only one road it can go through, and if a tree fell or something blocked it, then that's it, right? No more traffic, so no more current. So what happens? So you can say that current cannot flow. The circuit is no longer complete. It won't work. If you had bulbs, they won't light up. So if you had Christmas lights, you wouldn't want to, in some of the old-fashioned Christmas lights, they were put in series, and if one bulb went out, the entire thing went out, and it would have been a painful task to figure out which bulb. So now we use a different type, parallel. Let's also kind of review what happens in parallel. Let me see if I have similar questions for parallel circuits. If not, we can add that. I guess I can just mention it here. So if you have parallel circuits, if I added an extra resistor, that's kind of like saying if you had traffic going and it goes from point A to B, and it can actually split between two lanes. But now what if it could split between three lanes and then recombine? Would that ease the traffic flow or would it make it harder? It should make it easier for traffic to flow, right? If you have three different places where it can split and then eventually they all combine somewhere else, the same goes with that. So in a parallel circuit, adding an extra resistor or extra bulb actually lowers the resistance and raises the current. So if you added more and more bulbs in parallel, the overall current actually goes up and they will get brighter. So it's different. The total current will go up, all right? But you have to keep in mind that the current still splits between the different bulbs. But each, current, overall the current goes up, so each bulb will receive more current than it did before. All right. Now let's do a problem, number 7. Suppose that you connect more and more bulbs in a series to a battery. What happens to the brightness of each bulb as you add more bulbs? We already answered that they get dimmer, right? If they're in series, because of the reason mentioned here. All right, so now we are actually solving this problem. All right, so this problem actually this diagram goes with 8. It says the voltage drop across each resistor in the circuit above is, so now study the circuit, it's series, right? In series, remember the current is the same, which means the voltage splits. Now look at the resistors. They're equal resistors, so the split is equal. So 8 volts is going to split equally. So the voltage split, you can just leave it as a fraction if you like, 8/3. So 1/3 of 8, right? That many volts. Calculate the current through each resistor. The current is determined by the total resistance, okay? What's the total resistance in this circuit, first of all? In series, how do we calculate the total resistance? Those formulas I showed you, you simply add them up. So if you have 3 resistors, you add all 3. If you have 4, you add all 4. So it's 2 plus 2 plus 2, 6 ohms. And then we want to figure out, we already know that there is 8 volts across the entire circuit, has 8 volts applied to it. We want to figure out the current through the circuit, which is going to be this, it's going to be the same value through each resistor. So use the formula, again, write it down, V equals IR. V is 8 equals I times 6. So I is, you divide both sides by 6. I'm going to try to squeeze it here. So I will be 8/6. So 4/3. I'll just leave it as fractions. Fractions are better than decimal, but I don't mind if you did decimal either. So 4/3 of an amp. Any questions so far? So the current in a series is the same everywhere. It's the same through each resistor. Doesn't matter what the value is. Even if these resistors were different, even if you had like a 5, 2, and a 3 ohm, the total resistance with the total battery voltage, use the formula V equals IR to calculate the current. That current is the same everywhere. So this is the current through each resistor, as well as the total current. The current in a series circuit, now we have a multiple choice. Does the current change as it goes through resistors in series? We just said that the current is the same everywhere, so it doesn't decrease, right? It's the same at all points in the circuit. It's a bit of a repeat question here. 10 is B in series. Only in series though. Parallel, it splits. Current is never ever used up. Keep that in mind, so I may give you a true or false. That as the current goes through a circuit, it gets used up by the bulb. True or false? That's false, right? The bulb is not using up current. It uses up energy that each charge is carrying. It doesn't use up the charge. It's not like there's something eating up charge in there. The charge is the same flowing around. It's just that the energy that the charge carries is given, transferred. If it's a bulb, it's converted to heat. It's the same with resistors. The resistor is something that we use primarily for having resistance. Bulb also has a resistance, but bulb can glow because the current through a bulb can heat up the filament. All right, 10. In a series circuit, the sum of all voltages must drop. So in a series circuit, the sum total of all voltage, in a series circuit, the sum total of all voltage drops must, remember, they should add up to the battery voltage. So let's see. So it should be C, add up to the total voltage supplied by the battery. We've already discussed this. So we're done with the series. The series circuit's done. Now let's look at parallel circuit calculations. So for parallel, remember that the current splits, which means the voltage is the same across each. So it's 3 volts here, 3 volts there, 3 volts there. Now let's answer. The voltage drop across each resistor in the circuit is 3 volts. The current in each circuit in the resistor is, so you got to do the calculation for that. The current is determined by the total resistance and the battery voltage. So how do we calculate the total resistance for a circuit like this? Two ways of doing that. Either, I'll show you one quick way of doing that if all the resistors are equal. If they're not equal, you need to know. This is one of the things you did in the previous assignment. First, use the formula R total equals R1, R2 divided by R1 plus R2 on two of them. Then whatever you get, apply the formula again as if that combination is in parallel with the other 2 ohms. So it's going to be, so this one for the 2 ohms is going to be 2 times 2 is 4, divided by 2 plus 2 is 4, 1 ohms. So their total is 1 ohm. So now you're saying that there's a 1 ohm in parallel to 2 ohm. You repeat the formula for the full circuit. This is more like for 1 and 2, right? This is for 1 and 2, R1, 2, I'm going to call it. Then you apply the formula to a 2 ohm and a 1 ohm in parallel. So it's 2 times 1 divided by 2 plus 1. So 2/3. That's the total resistance of this circuit. The battery voltage and the total resistance determines the total current. So first, let's determine the total current. And that current then eventually will split in 3 parts between the 3 equal resistors. So let's calculate. So the formula is V equals IR. To calculate the total current, you use the total resistance. V is 3, the battery voltage, I total times 2/3. You divide both sides by 2/3. You can work in decimals if that's comfortable for you. But when you do this, or you can cross multiply, this 3 ends up there. So it's 9/2 amps. If one side you have 2/3 and you divide both sides, the other side, it'll become 3/2. So 3 times 3/2. That number of amps splits equally between 3 resistors because all 3 are equal resistors, right? So what's the current? It's a third. So the current in each resistor circuit is 1/3 of that, because there are 3, which is 3/2 amps. The shortcut way that I told you, if you had 3 equal resistors, their total resistance is 1/3 of each. If there are 2 equal resistors, then their total resistance is 1/2 of each. But for that to work, the resistors have to be the same. Any questions so far? So this is all your assignment as 3-6, that what you did. All right, now let's answer a multiple choice here. So when a resistor or a bulb is added to a parallel circuit, the total circuit resistance, in that case, it decreases, right? We discussed that. In series, it increases. In parallel, it decreases. What are the differences between series and parallel circuits? You can pretty much just summarize what we did up here, right? That in series circuits, I'm just going to say it out loud and you can just make some bullet points there. In series circuit, the current only has one path to go. It's the same everywhere. The voltage splits. In parallel circuit, the current splits between the different resistors, and the voltage is the same as the battery voltage for each resistor. Adding an extra resistor to series increases the resistance and decreases the current. Adding an extra parallel resistor to the parallel circuit decreases the resistance, increases the current. So those are the things you really need to know. You can go back and watch my video too. I just said it out loud. But I mean, all of what I said is summarized up here in different parts. Now let's do some more calculation. It says a series circuit contains a 12-volt battery and 3 resistors, 1, 2, and 3 ohm. Draw a circuit diagram. So you should be able to do something like this. So it's series, so you do 1, to 3 resistors. It doesn't take that long. That's 1 ohm, 2 ohm, 3 ohm, 12-volt battery. So our diagram is done. What's the total resistance? Simply add 3 plus 2 plus 1, 6 ohms. That's series. What is the current in the circuit? Remember V equals IR again. The battery voltage. Now I'm just going to do it in a few steps. Now on the test, I recommend that you show me your work, like you write down everything you know, like this. And R total, you already have that up at the top, 6 ohms. You're looking for I. And then write the formula, plug it in. So it's going to be 12 equals I times 6. Divide both sides by 6. So I is 2 amps. 2 amps is the current through each resistor. What's the voltage drop across each? Now it's tricky, right? Because the 12 volt does not split equally. So if the 12 volt doesn't split equally, how do we calculate the voltage across, let's say, 3 ohm? Use this formula for that resistor. For resistor 3, use V equals the I through that resistor. Every resistor is 2 times its resistance is 3. So 6 volts out of the 12, the 6 volts actually drops across the 3 ohm resistor. What is the voltage drop across 1 and 2? You can do a separate calculation. For 1 ohm, it's going to be V equals the current through that, I, times its resistance, 2 volts. For the 2 ohm, V equals I, which is 2, times 2, or 4 volts. These should all add up to 12 if you did everything correctly. 6 plus 4 plus 2 is 12 indeed. So we didn't make a mistake. That's how you check. So that's your series where you had to draw it yourself. Any questions? I'm going through it fast. Tomorrow, take your time, watch my video, go through it again. We've done this in worksheets before. Draw a diagram of this circuit in the space on the right. A 12 ohm, a 6 ohm, a 12 ohm and a 6 ohm bulb are connected in parallel. So quick diagram. That's parallel. And that's the battery in parallel. Label it. That's 2 ohm. That's a 6 ohm. Oh, these are bulbs. So instead of a resistor, you can just do that. Oh, sorry. It works for the resistor as well. Well, there you go. In the previous one, I didn't notice whether it was a resistor or a bulb. So let's just make sure. Yeah, it was resistor in the previous one. Anyways, that, and then the battery voltage is 3. What's the voltage across each bulb? That's the easy part. For parallel, the voltage is the same because current splits. So it's 3 volts each, right? There's a 3 volts here and a 3 volts there. Remember, voltage is always measured between 2 points across a bulb. What's the current through the 2 ohm? Notice that out of the 3 variables, I, V, and R, you have 2. You just got to figure out the third variable. So let's do that for the 2 ohm. For the 2 ohm, I have R is 2. V is 3 volts. I need to figure out I. Use the formula V equals IR. Calculate I. V is 3 equals I is the question mark, R. Divide both sides by 2 and you get I equals 3 over 2 amps. You got the idea? You do the same for 6 ohms. I will be, instead of 3, now you, yeah, so you have 3 divided by, instead of 2 ohm, you have 6 ohms. So half an amp, right? Because like so. What's the total current? The total current is what splits into for 2 ohm to be 3/2, for that one to be half, you add those two, right? When you add those two, you can get that, or you can first calculate the total resistance and work it like that. So I total is 3/2 plus a half, which is 4/2, which is 2 amps. What's the total resistance? The total current and the battery voltage will determine the total resistance. If you use the formula, V equals IR. So if you use V equals IR, the battery voltage is 3. The total current is 2. So R total, so these will be the total this time. So how do we calculate it? You divide both sides by 2. So R total is 3/2 ohms. And the way to check that answer is this should be smaller than either of those, right? That doesn't guarantee that you did it correctly, but it should at least be smaller. So look, 3/2, right, which is 1.5 is smaller than 2 ohms or 6 ohms. So we're done with that. Any questions? That was the last question. We actually did finish it. Yeah. So